Good day, everybody. How are you all? Doing good? So, today we are going to talk about retirement savings. But before I get started, I will mention that in my channel, I have solved all kinds of problems in math just for you: statistics, calculus, algebra, trigonometry, geometry, plus some prep material for GRE, GMAT, ACT, cat, you name it, I got it. So please subscribe to my channel because then you'll have access to all my YouTube videos through playlist. I have all kinds of playlists made just for you. Okay. So please subscribe to my channel by hitting the red subscribe button. And now let's get started. Find the principal P that must be invested at rate R compounded monthly so that $1 million will be available for retirement in T years. Rate is 6%, T is 40 years. We will use the compound interest formula, which gives A is equal to P multiplied by, in parentheses or in brackets, 1 plus I over N, close parenthesis, exponent is NT, raised to the power of N times T. A is the amount after T years. P is the principal, uh, is the initial investment. I is equal to interest rate in decimal. Remember, we have to plug in the decimal value. And N is the compounding period. T is the time in years. Okay. So in this particular problem, amount, what we have after 40 years of saving is $1 million. Our I is 0.06, N is 12, and T is 40 years. Okay. So we have $1 million equal to P, then in parenthesis 1 plus interest rate, remember in decimal is 0.06. That has to be divided by 12 because you're compounding monthly. So divided by 12, close the parenthesis, exponent is 12 years, 12 months in a year multiplied by 40 years. So N is 12, T is 40. So 12 times 40 is 480. Or we will, so this 1 plus 0.06 divided by 12 is actually 1 plus 0.005. So it's 1.005 exponent 480. Now you can divide by 1.005 exponent 480 on both sides, and your P, then you will be left with P on the right hand side because you have divided by 1.005 exponent 480 on both sides. So on the left hand side of the equation, it will be 100 or 1 million divided by 1.005,480 exponent 480. So, and that is equal to P. So P is actually equal to 1 million multiplied by 1.005. 0.005 is coming from 0.06 divided by 12. And you have divided by 1.005 exponent 480. So on the left hand side, it would be 1 million multiplied by 1.005. Exponent will be negative 480. Why? Because you're dividing by 1.005 exponent 480 on the left hand side. 1 million is divided by 1.005 exponent 480. When you bring the exponent to the numerator, it becomes negative. 1.005 exponent minus 480 now multiplied by 1 million. And the principal that you have to save, that you start with initially at the beginning of 40-year period, is 91,262.08. So I will stop here today. If you have any question, please write me a comment. I'll get back to you as soon as possible. You can also, contact me or write me a note through WhatsApp. My WhatsApp number is the third line, is at the third line in the description panel. Okay. And please subscribe to my channel by hitting the red subscribe button at the bottom right corner. I'm coming back next time with another interesting problem solved just for you. Take care. Have a nice day.